Hi guys. So a while ago, I was looking into some problems that were cropping up in the application. This has got nothing to do with the issues that I was looking into, but I spotted one of the tables, every single column, 20 of them, 20 columns, all defined as a Varchar MAX. I mentioned to the developer, I said, you know what, this might not be a great idea, you might want to look at this. And he turned around and said, why? Why not? Why shouldn't we just spam Varchar MAX across all of our columns? It gets rid of that really annoying issue that crops up when we insert a value and it overflows the data type. So why shouldn't we? Why shouldn't we just spam Varchar MAX over everything? Should we check it out? Hi guys, so I'm David Fowler from SQL Undercover, and in this little video I want to look at why we shouldn't just use Varchar MAX. So to investigate this, I've created a few tables. Okay, we've got two tables we're going to look at to start with. We have one table, Varchar test 1000. Now that contains two columns. We have an ID column, which is an int, and we have a notes column, defined as a Varchar 1000. We also have a second table. Data is exactly identical. There's no difference in the data. The data in the two tables is identical. It's identical data, identical number of rows, 1,000 rows in each table. The only difference is this one still has an ID column of an int, but the only difference is the notes is now a Varchar MAX field. And I want to see how the two behave. What is the difference? So for this little demo, one thing I'll admit straight before we start, this little demo, I have disabled memory grant feedback, okay? Just because it interferes with my results a little bit, okay? It does. If you want to know more about memory grant feedback and how it can help and the sort of issues we're going to look at, feel free to go and look it up. Maybe I'll do another video on it. But for this example, it's switched off. I just want you to be aware that it is switched off as well, just for consistency of results. So the first thing I want to do is run these two queries here, okay? We're going to select ID and notes. Firstly, from the Varchar 1000, test 1000 table. Secondly, we'll then select ID and notes from Varchar test max. So let's just run those off. As I said, the data in the two tables is exactly identical. It's 1,000 rows, identical data set. So let's just have a little look at the execution plan. So on first glance, the execution plans look pretty much identical. We've got a table scan going into a select, another table scan going into a select. But what I do want to look at over here is the estimated row size. So this is the interesting thing. So in our Varchar 1000 example, our estimated row size comes in at 515 bytes. Now let's look at the same thing for our Varchar MAX test. Our estimated row size is now 4,039 bytes. That's a big difference. That's a big difference. And why? Why is there a difference? The data in both tables is exactly the same. Why is there a difference in what SQL has estimated for the row size? Well, this comes down to how SQL figures out its memory requirement estimations. It needs to work out, have a guess, how big a row is going to be. Now, if a row is made up of fixed length data types, ints, chars, bits, date times, etc., SQL's got it easy. It's easy mode for SQL. It knows exactly how big each column is going to be and therefore how big the row is going to be. Once we start throwing in variable length data types like varchars, nvarchars, SQL is going to have to start doing a little bit of guessing. It doesn't know how big this column is going to be. A varchar could be anything from 1 to 8,000 bytes. Varchar MAX can go up to 2 gig. So how does it work this out? Well, what it's going to do, it's going to assume an average of 50% fullness. So what does that mean? Essentially, what SQL is going to do, it's going to look at the maximum length of a data type and half it. So therefore, when estimating the row size for our Varchar 1000 table, it's going to do two things. We're going to look at the int. Okay, we know we've got an ID, that int field. It knows that's 4 bytes. That's easy. It's then got to deal with a varchar. okay, with a notes field. Now, we've defined in Varchar 1000 a Varchar 1000. So therefore, SQL, going by that 50% fullness assumption, is going to guess 500 bytes. Okay, so we've got 4 bytes for the int, 500 bytes for the varchar. SQL actually came up with a number of 515 bytes because it adds a little bit of overhead onto that. But that's how it works it out for that particular query. So what about our Varchar MAX? What's going on there? It's got to do a similar thing. It knows the length of the ID column. We know that's 4 bytes. That's easy. But what about the Varchar MAX, okay? A Varchar MAX, the maximum data a Varchar MAX can store in row is 8,000 bytes. Yes, I know it can go up to 2 gig, but once we get above 8,000 bytes and we start going off-road, things get interesting, and I don't really want to look into that too much here. So assuming, looking at 8 bytes maximum row size in row data, SQL is going to assume 4,000 bytes. Again, with a slight overhead. So SQL has taken, in this case, it's taken the 4 bytes from the int, and it's taken around 4,000 bytes plus some overheads to come up with an estimate of 4,039. So take a little second to think about that. In our example, we know we're never going to exceed 1,000 characters. But because we've assigned a column to Varchar MAX, SQL doesn't know that. SQL doesn't know that we're not going to exceed 1,000 characters. We very well could. So SQL needs to take that into account in its estimations, which is why it's massively estimating that row size. But why does that matter? Why does it matter if SQL's overestimating a row size? So when SQL executes a query, it needs to allocate a certain amount of memory. Complicated things like sorts and joins all need space to store their intermediate results in memory. This memory is generally allocated before the query starts running. So how does SQL know how much to allocate? It has to estimate. It works out a memory grant estimation. And as you probably guessed, one very, very important piece of information it uses when estimating row size, when estimating memory grant, is the row size. So if we're overestimating row size, then we're going to be over-allocating memory. Now, I want to run another couple of queries here just to see what happens. So we've got very, very similar to before. We're going to select ID and notes from Varchar test 1000 and ID and notes from Varchar test max. We're going to now order, I've had an order by notes just to give SQL something to do, something a little bit meaty for it to get its teeth into. So let's just run these. And if we have a little look at execution plans, we can see they're very similar. We've got a table scan, a sort and a select for a Varchar 1000 query, and a table scan, a sort and select for our Varchar MAX query. Although, check out the select. We've got ourselves a little exclamation mark. You know, SQL is having a bit of a grumble with something about that Varchar MAX query. What could it be? Well, I'll tell you what, before we look directly at that, let's have a little look at the memory grants that we're seeing. So for our Varchar 1000 table, we can see SQL has asked, or the query has asked SQL for 1,600K of memory. It has used 176K of memory. So already we're seeing that SQL has granted more memory than the query is actually used. But you know, that's a fairly small amount, isn't it? Let's have a little look. The same thing for our Varchar MAX. Let's go in now. Okay, so we can see max memory used 208K, but it has granted a whopping 6,656K. That is a huge overgrant. That's massive. That is a lot of wasted memory that SQL is giving this query that's not being used. Yeah, granted, a few thousand K here or there isn't a massive amount in the grand scheme of things. But remember, this is only a table with one Varchar MAX column. It's only got 1,000 rows, and it's a single query. Add more columns, add a larger data set, a more complicated query, and you can start seeing why this could become a problem. too many queries like this running at a time, and you can easily hit the issue where SQL is going to run out of memory to grant. And what happens when that happens? SQL queries have to sit and wait. They're going to have to wait, they're going to be slowed down, and that's going until memory frees up. We start seeing resource semaphore waits in the wait stats. Another bad side effect is that this is going to start putting pressure on our caches, on our plan cache, on our buffer cache. It will force eviction from those. That then in turn leads to increased compilations as well as increased I/O, which is further going to impact performance on our server. Okay, I hear you saying, why are we ordering by notes? That's stupid. Why would we order by notes? You know, who's going to order by a Varchar MAX column anyway? That's a silly thing to do. All right, no worries. Let's change it. Let's try ordering this time. Order by ID. Okay, so we're going to do the same query. We're going to select ID notes, Varchar test one from the Varchar test 1000, ID notes from the Varchar test max tables, and we'll order by ID. So the ID is our int field. Let's have a look, see what happens. And if we look at the execution plans, well, we have still got on our Varchar MAX, we are still seeing that little exclamation mark there. It is still grumbling. Why is it grumbling? An excessive memory grant has been detected. Grant size 6,656K, only used 208K. So even though we're not ordering by our Varchar MAX column, it is still impacting the memory grants. Why? Well, if we look at our execution plan, we can see that even though we're not ordering by that Varchar MAX column, it's still being passed through into the sort. It's still being taken into consideration in the memory grants. So let's take this a little bit further, okay? This is only a very, very small table. But what happens if we have a table that's similar to the one that I saw in production when I was looking into this issue? Let's have a look at our Varchar MAX silly table. In this case, we have got 1, 2, 3, 4, 5, 6, 7 fields, okay, of Varchar MAX, which clearly, you can see by the name of them, they don't need to be. Now, this is very, very similar to the table I saw in production. Only the one that I saw was far worse. It had 20 columns. There's 20 columns of Varchar MAX. But this will illustrate the point. So let's have a little look here. We're going to do a select star from our Varchar silly, ordering by first name. Okay, let's see what happens. Let's look at our plan. Okay, so again, we've got ourselves a little exclamation mark. We've got ourselves a warning. But look at this grant now. Look at this grant. 39,112 kilobyte grant with only 288K used. That is absolutely ridiculous. That's absolutely bonkers. And again, this is only a small table. It's only got 1,000 rows in it doing a fairly simple query. Think how this could blow completely out of control with a decent number of rows. Let's go, we're going to the millions of rows. Let's add some complicated aggregates and joins in there, and you can see these memory grants blowing completely out of control, all because of the Varchar MAX. So that's memory grants. That's my biggest bugbear when it comes to Varchar MAX is memory grants. But what about indexing? What if we want to come and index this table? Let's try it, okay? Let's try it. Let's create a non-clustered index on first name. Seems like a pretty sensible thing to do. Let's do it. Oh, gosh, nasty, nasty red error message straight away. Column first name in table Varchar MAX silly is of a type that is invalid for use as a key column in an index. So we can't use Varchar MAX columns in an index. It just can't be done. So if you've got an excessive use of Varchar MAX in your database, another issue is you're not going to be able to index on them. So if your developer does come to you and says, why not just use Varchar MAX everywhere? I'm hoping you can now give him some fairly compelling arguments against it. As always, don't be lazy with your database design. Data types are one of the most important choices that you're going to make when you're building your database. So take time to think about them and choose them sensibly.